we've learned how to draw our electron dot structures, and then this module, we're getting into what shapes we get out of that. And so, what we have here is we've got our electron dot structure for carbon dioxide and our electron dot structure for water. And these are models of carbon dioxide and water. Are they the same shape?
No.
Do they both have the same number of atoms?
Yeah, they both have 3.
They both have 3. So what's different between carbon dioxide and water?
Well, this one's got 2 loopy things, and this has got little paddles.
Right. It's got little ear-looking things. If we look at our electron dot structure, what do we notice about our carbon dioxide?
It matches.
It matches. It's got our 2 bonds. Does it have anything else on carbon?
No.
It's just got the bonds. Here, we've got our bonds. What do we have up here?
We got lone ones.
We've got lone ones. And so what do we think our little ears represent?
Our paddles are the lone.
These are our lone pairs. And so what did we learn when we looked at our PhET simulation? Well, and actually even before that, what do we know about electrons? What kind of charge do they have?
They're negative.
They're negative. And if we've got negative things and negative things, what are they going to do to each other?
They push.
They push! They're like magnets. When you try to put 2 north poles together, they're going to push apart. So electrons want to be as far apart as possible. Here, we just have the bonds. They're going to push all the way apart and be linear.
Like a line.
Like a line. Here, we've got our bonds that are pushing apart, but we also have our lone pairs that are pushing apart. And so what does that do for our shape?
Bends it.
It bends it. So our shape is
Bent.
bent. This is what water looks like if we don't include the lone pairs. But it's bent because of the lone pairs.
Bent.
Yeah, whenever you're ready.
All right. So we just looked at comparing carbon dioxide to water. And so carbon dioxide had no lone pairs, it was all in a straight line.
Linear.
Water had 2 lone pairs, so it was
Bent.
because our electrons push away. So the next one we want to compare is NH3 and BF3. So what does NH3 have if we look at this and we look at our structure?
They've got the lone pair.
They've got the lone pairs, and so what does that do to all of our atoms that are bonded?
It pushes them.
It pushes them down. And so what kind of shape does this make?
It's like a pyramid.
It's like a pyramid. It's a trigonal pyramidal. What does it mean that it's trigonal?
Tri.
3. All right. So this is also trigonal,
Yes.
but what's happened to this one?
It's flat.
It's flat. And so in math, we learned that things that are all in the same flatness,
Are on a plane.
they're on a plane, so it's trigonal planar. And so B doesn't have any lone pairs. It's just
Flat.
flat,
Like a plane.
like a plane. All right.
Not this kind of plane.
We've looked at some different shapes. Now is our last shape. So this one is CH4. And so we have just bonds around. Do we have any lone pairs?
No.
So what are all our bonds doing?
Pushing.
Pushing, and so they all push out to different corners. What's this one called?
Well, when you had it like that, it looked kind of like a pyramid.
It's kind of like a pyramid,
Kind of.
but not really. This is actually one of our weirder names. It's a little harder to remember. It's tetrahedral.
Because tetra is 4.
Because tetra is 4. Think like Tetris. All your pieces have 4 parts. So it pushes all of our bonds apart
Equally far.
equally far. And so it's tetrahedral. How many atoms are in this?
5.
5, but how many atoms are around?
4.
Anytime we got 4 atoms around, it's going to have to be tetrahedral. That's the only thing we can do. So, to remember, if we've got 4 atoms around, it's
Tetra.
tetra, it's tetrahedral. If we only have 4 atoms total, and so we have 3 atoms around, it could be 2 things. They're both going to be
Tri.
they're both trigonal. This one is
Pyramidal.
pyramidal. It looks like a pyramid. What does it have that this one doesn't?
Lone pair.
Lone pair. This one is going to be trigonal
Planar.
planar because it's all flat,
Yes, like a plane.
like a plane. And so then, if we've got 3 atoms, we've got 2 choices. We have
Linear.
linear, it's all in a line, and we have
Bent.
bent. And so what makes this one bend and this one not?
Lone pairs.
Lone pairs. In general, we would have to make sure that our electrons are pushing as far apart as possible. This is why overall the study of the shapes of molecules is VSEPR. Valence, shell,
Oh, shell.
electron, pair,
Pair.
repulsion.
Because
All
they're
our,
pushing.
they're pushing. All our electrons are pushing away.
Okay.
Okay, so we've talked so far about 2 types of bonding, really. We've talked about ionic bonding, where we have one thing, usually our metal with a plus charge, and one thing, usually our non-metal with a minus charge. And we know that ionic compounds are brittle, and that's because if you have a plus and a minus, they hold together really tight. If you try and shift them apart at all of a sudden my plus lines up with my plus, or my minus lines up with my minus. We just talked about opposite or like charges repel, it all falls apart. Covalent things aren't going to make nice structures like that usually. We've got 2 electrons being shared, and that's the only bonding going on, so they're generally going to be very distinct parts. Metallic bonding is our last type of bonding. Metallic bonding, like it sounds, takes place just between metals. And so in metals, you've got your atoms, and there's not one bond. There's not charges. Just everybody sharing all the electrons. This is called the sea of electrons. The sea of electrons is just everybody's sharing all of the electrons. Because of that, metals are malleable. If you take 2 atoms, there's not really a fixed bond. They'll just slide past each other. So if I smash it with a hammer, I can just smash it out flat. Same thing with ductility. I can draw it into a wire. They'll conduct electricity because you put electrical current through this and just shoves all your electrons along. So metals are even shiny because of the sea of electrons, because we talked about electrons getting excited. When light bounces off of my metals, it excites our electrons, they fall back down, it shines off some light. All of the properties of metals come back to our sea of electrons. We're all sharing all our electrons evenly. It's an electron commune.
Hey guys, I'm here to give you a little chart that you need to copy down. This is going to help you with all these different shapes that you just learned. Okay, so the linear shape you learned looks like a straight line. It's going to have 3 atoms in it. So it looks like this. There's 1 atom in the middle of 2 other atoms, and they're bonded together like this. So that means that there are 3 total atoms here, and they have 0 central atomic electron pairs, because there's no paired electrons around the center atom right here. Okay, to have a bent one is also going to have 3 atoms, but it's going to look like where our central atom is kind of making a peak on the top with a couple of lines and a couple of atoms on the sides like that. This one is going to have 2 pairs of electrons on the central atom. So you're going to see 2 little dots on either side like that. That's what gives it its bent shape. Okay? The next one we're going to talk about is the trigonal planar. The trigonal planar has 4 atoms in it. It's got 1 central atom, and it has 3 atoms, 1 on each corner like that. Okay, so because it's a flat shape like that, it does not have any central atom pairs. Okay, the pyramidal, that's going to look similar to the trigonal planar, except the central atom is up top here, and it's making like a pyramid. So it's going to have 4 atoms also. But it's also going to have a pair of central atom electrons on top. So that one has 4 electrons in 1 pair of central atom electrons. And then there's the tetrahedral. The tetrahedral is like the pyramidal, but instead of the 2 electrons on top, it's got a 5th atom on top. So here's my central atom here, 1 coming down, 1 off to the side, 1 off to the side, and 1 on top like that. That means there are 5 total atoms, but 0 central atom electron pairs.